Hi everybody, Dr. Nigro again with our last video in our stoichiometry series for chem calculations. All right, as I mentioned before, stoichiometry is a dimensional analysis type of problem. All right, here instead of using metric prefixes or molar mass to moles with the single compound, we actually are going to be converting between components within a reaction. So our problems will always include a mole ratio step. All right, and that mole ratio step requires the coefficients, which means we need a balanced chemical reaction. All right, so we've done a one-step problem, which was moles to moles. We've done a two-step problem, which was grams to moles. Now we're going to look at the final type, which is grams of hydrogen gas, if we start with grams of a different component, in this case, hydrochloric acid. All right, so again, as always, I like to do a little plan. Whoops, except it's not 8. Sorry about that. 3. So HCl, and we're trying to convert this to grams of hydrogen gas. All right, so we look and see if we know any conversion factors that let us do a direct conversion there, and the answer is no. All right, I'm going to convert first to moles of hydrochloric acid. All right, I do that using the molar mass of HCl. All right, I still can't go to grams of H2, so I need to convert one more step to moles of H2. All right, and there's our mole ratio step. And then I'll be able to go to grams of H2 using the molar mass, but this time for hydrogen gas. All right, so there's our plan. All right, so we set up our problem by starting with our 55.3 grams of HCl. Our first conversion factor, we'll put that unit, grams of HCl, on the bottom. And we said based on our plans, we're going to moles, so that goes up top. And that we need our molar mass to make that happen. So I use my periodic table, and I find that 1 mole of HCl has a mass of 36.46 grams. So that's going to let us cancel the grams of HCl. All right, our next step we said is going to be the mole ratio step. So the mole of HCl goes in the bottom, so it will cancel. The moles of H2 go up top. I go check my balanced chemical reaction, 2 moles of HCl, 1 mole of hydrogen. So I put a 2 in the bottom, a 1 up top. Those units are going to cancel. Now I'm at moles of H2, but I need grams. So my last step is a molar mass step. Moles of H2 in the bottom, so it'll cancel. Grams of H2 up top. And 1 mole of H2 has a mass of 2.02 grams. So that's going to cancel the moles of H2. And then we just do the math, and we find that if we have 55.3 grams of hydrochloric acid, I can produce 1.53 grams of hydrogen gas. All right, so if we look back at the problem, we have 3 steps this time, all right, because we're going from grams of one component to grams of another. So when the word mole does not show up in the problem, chances are it's at least 3 steps. All right, we started out with our molar mass step using that molar mass of hydrochloric acid. In the middle was our mole ratio step, where we went and looked at the coefficients. And then we ended with a second molar mass step, but this time for hydrogen gas. Okay, so when you're working these problems, I really do think that having some sort of plan, at least initially, is a good idea. Now, eventually you may not need that plan, but at least to remind yourself of what the steps are to get from what you have to start with to what you need at the end. I cannot stress enough how important stoichiometry is for the rest of the year. We do all kinds of problems that have a component of stoichiometry in there somewhere. All right, the rest of the videos for this unit are going to include problems with percent yield, limiting reactants, and excess reactants, and all of those will require stoichiometry. All right, so if you're having problems with the stoichiometry, please make sure that you ask for some help, okay? All right, see you in class.